Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 22nd February 2023. The problem statement for today is connect nodes at same level. This problem is based on tree data structures and has been asked in many companies like Flipkart, Microsoft, Amazon, Adobe, Google, and many more. So let's now open this problem. Let's understand the problem clearly first. Here it is saying given a binary tree, connect the nodes at the same level. The structure of the node contains an additional right next pointer for this purpose. Okay, so it is mentioning that there is one extra pointer which is there with the name next right. Okay, initially all the next right pointers point to garbage values. Your person should set the pointers to point right next for each node. Okay, so initially it is pointing to some garbage value, but we need to set these pointers to point next right for each node. So 3 should point to 5, 4 should point to 1, something like that. So here it is showing the how this next right pointer is being used here. So initially this for 10 the next right will be null. For 3 it will be pointing to 5, and from 5 it will be null, and for 4 it will be pointing to 1, from 1 to 2, and 2 to null. Okay, so let's go through the example first. So first example, here it is saying that the tree structure is something like this, which contains 3 nodes. That is 3 is the root node, left child is 1, right child is 2. So 3, 1, 2. So if we look at this output, then it is giving two output, 3, 1, 2 and 1, 2, 3. 1, 3, 2. So if you can see the first output is the level order traversal. That means we will traverse each level and we will keep printing those nodes. So it is level order traversal 3, 1, and then 2. And if you see the second output, it is in order traversal. That means first we are printing the left child, then we are printing the root, then we are printing the right child. So the second output is the in order traversal. So this is that the connected tree is in this shape. So from 3 to 1 and 1 to 3. Okay, so now let's look at the second example. Second example, here it says this is the tree structure. So the first output, as we have discussed here, it was level order traversal. So we'll see, is it that way only? So in this level, only 10 is there, 10 is there. In next level, 20 and 30 is there, 20 and 30 is there. Next level 14, 16, then 14, 60. And second output was in order traversal. So for each node, first we will print the left subchild, then then root, then right child. So here if we are starting with this one, then left child is this one. So before printing this 20, first we will see, does it contain any left child? Well, yes, 40. So 40 will be printed first, then 20, then 60. Then this is that root node, then so 10, and then after that 30. So first one is level order traversal and second one is in order traversal. So here the thing is that we have to print, that means the output will be in this order, that means level order traversal and in order traversal, but we are not supposed to print the output. If we were given the privilege that we have to print the output, then we could simply do level order traversal and in order traversal and we could print the output. But here if we open this code, that means this driver code is there, and here we see how these are printing. So first this method is called, that is print special, then print in order. And while printing, so if you go to this implementation print special, then this is the print special node through which we are getting the output as level order traversal. So in this print special, if you see, then see here it is using this one next right pointer here. So this code is using next right pointer. That's why we are asked to set this next right pointer for each node. else it was not required. Simply if we have to do level order traversal, then we could simply do it using queue, and we will keep pushing the left child and right child of a particular node, and as and when we remove it from the queue, it will be printed. So we can print those removed one, because we know the property of queue. The node which will enter first, that will only get out first. So if I push 10 there, and after that we see if 10 contains left child, then yes, then we will insert 20, and after that we see if 10 contains right child, then yes, then we insert 30. So the queue structure will be 10, 20 and 30. After that we will see whether 20 contains any left child, then yes it contains, then 40 will be inserted. Then we will check whether 20 contains any right child, yes 60 is there, the 60 will be inserted. So 10, 20, 30, 40, 60. So in this order nodes will be inserted into the queue. So and that only is that level order traversal. But here instead of we printing it, we have this code is printing using next right pointer. That's why we need to set this next right pointer to point to appropriate node, so that it can fetch output in the level order traversal. So keeping this approach only in mind, so let's now start coding for this. I'll be explaining each line of the code while coding as well. So now let's go back to here. So we will be doing here level order traversal only, but instead of printing, we will be setting the next right pointer for each node. That's it. We will be doing, instead of printing it, we will be setting at that place where we used to print in level order traversal. So for what we will do, first we will create a queue of node type, because here the node is given node type, and we'll just name it with a queue. We'll be saying new linked list. So, and to this queue we will first add root. That means the node which has been given to us, that we will add, that we have been given root node, so we will add. Now we will do the traversal while queue is not empty. So until queue is not empty, we have certain operations to perform. That means we will keep checking the left child, right child, and we'll keep assigning in the next right pointer of a particular node to the next node. So we'll check this. If it is not empty, then we'll do the following operation. So here we can define a node which we can call as a previous. So previous node is created to hold the value of the current node in the next step. That means at the point when we are reaching 20, that time we see here for 10, 20 is the left child. So current, if it is pointing at this 10, and now if we move to this 20, so at that moment whatever was the current in the previous step, so that we will assign to previous. So that time we can assign that previous of next right is equal to which new current one. I hope it is clear that prev dot next right, we will assign the current value. That means the current value whatever we have. For that we have created this previous node, and here we can create we will run a for loop. We will run a for loop for see whatever the node whatever the values are there in the node in each level. For iterating them in each level, we are creating a for loop. That means for first time it will be 10. So when we are accessing 10, that time we will insert into this queue 10 and 20 and 30. But this for loop will end here, this 10. But for the next level, it will start with 20 and it will go up to 30. And for each step, we will keep adding the child elements into the queue. So here we will see, here we can I less than, see here we need to define size. Int size is equal to q dot size of, and that we will use here. See, it is very important here that we need to understand that we cannot use q dot size method here. See, it is very easy to say that this is a variable simply holding the q size. No, but the thing is that here it will hold the size when this while loop is running. So at each level so that whatever the size of that particular q in that time, so that value we will hold here. That's why I said that for each level it will hold the values, this size one. But if we add this q dot size here, then at each instance we will be adding left, right, and left child and right child as well. So this q size will be keep on changing in this inner for loop. That's why we are using this outer the variable which is defined outside this for loop. That means for each level. So here I plus plus. Now what we can do here, simply we will start doing thing. What we'll do, we'll simply make a current node. And what will be the current node? Current node will be q dot remove. Q dot remove whatever the element is there in the front of q that we are removing, and that we are marking as a current. So here initially only root will be there because we have added just root there. So this current element will be pointing to this root node, that is 10. Now what we will do, we will just check here if current not equal to null. So here current is not equal to null because it has a value that is 10, that means node that containing 10. So now we'll check here. Since it is not null, then we can check if current is having any left child or not. If current dot left not equal to null, then what we'll do, we will add this to q dot add. Here we will do current dot left. So see, for this reason only I was saying that not to use this q dot size function here, because each time once we add this one, then the q dot size, this value will change, but we are traversing each level wise. So that's why this is not used, and we are just keeping it outside this for loop, inside this while loop till this q is becoming empty. Okay, because in each iteration the q size is dynamically getting changed. That's why we are not using that q dot size in this method here. So here now we can again check if current has any right child or not. Current dot right not equal to null, then q dot add current dot right. So in this one till now we have checked if it is having any left child, then add to that q. So initially current will be 10, so current dot left will be 20, so 20 is added to the q. Then we are checking with current dot right not equal to null. Yes, it is not null because 30 is there, so 30 is added to the q. So at this moment q will be containing 10, 20 and 30. No, 10 is not there because we have already removed it. It will contain 20 and 30. Okay, so now once this is done, then we'll check if this previous whatever we have defined here, if that previous is not equal to null, then here we will do previous dot next right, it will point to current and here if it is null, that means if it is null or for the subsequent operation if it is not null, then also we will assign the current value in previous, so that for a next node the current one in this current iteration, that will act as a previous for the next iteration. So it will be current. So here if you try to understand this one, so once we we are at 10 here. We are at 10 here. Then we are saying current is not equal to null. Okay. The current dot left not equal to null. We are adding 20 and 30 to the queue. Then we are checking if previous is equal to null. Then yes, initially previous was null. So it won't do any operation. It will simply point previous to current, which was 10, which will be 10. In the next time, next iteration, when it will come here, then here it will check for this one. Now the current will be 20, because this is, now we are removing whatever was there in the queue, in the front of the queue, that we are removing. So now this current will be pointing to 20. We are again checking, is 20 not equal to null? Yes, not equal to null. Is it having left child? Yes, left child is there. Right child? Yes, right child is there. But we are checking if previous is not equal to null. Yes, this time previous is not null, because previous is holding the node 10. So now what we are doing, we are marking previous dot next write. That means next write of this 10 node, we are pointing to current. That means from 10 it will point to 20. From 10 it will point to 20. So this way it will be easy for us to print this. That means the method which is there, special print. So that will use the next write pointer to print this one. So 10 will point to 20, 20 will point to 30. From 30 again it will point to 40, 40 will point to 60. So it will just keep on incrementing the next write pointer, and it will just keep on printing in the method which we have seen here. A special print, where we are every time it is checking for the next write. Okay, so I hope this point is very clear. So this we are done with our coding. I hope this is very well understood. And for each iteration, wherever we get that the previous is not null, then we will store next write of the previous to the current node. That means the current one which is in reference. If 30 is the current one, then for this prep will be 20, and 20 next write we will mark to 30. So I hope this is clear. So now let's try compiling this code. So here we can see we have got our output correctly printed. So that means we have correctly set the next write pointer for each node. Now let's try submitting this solution. So here we can see we have got all the test cases passed, and we have solved this problem successfully. Yeah, so that's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. And if you have any doubt related to this problem or solution, you can comment on this video. Yeah, so that's all in this video. Thank you for watching.